Okay, happy Wednesday. We're going to go get started on what we're going to do today. And today we're going to do something that should be kind of fun and lead you to some ideas for your game project that you're going to have to do here later this semester. But we're going to talk about, we're going to start talking today about making a tile-based game world. And we'll get into what that means in a second, and then we'll get in really far into the programming today. And then over the next couple class sessions, we're going to add to this and enhance it until you have something that's like almost like a little mini tile-based game renderer / engine. So let's go ahead and get started with going over this today. So first off, tile-based worlds. The idea there is that a lot of games use a technique like this where the map is composed of little tiles. And the idea is you have a palette of tiles that gets loaded into the memory. And then you stick those tiles together kind of like you would stick dominoes together or take pieces of paper and stick them on a wall to make like a banner. But the idea is you stick those tiles together to create the game world and game map. And the tiles can create the graphical appearance of the world, but you can also have the players and characters interact with those tiles in some way. So for example, some tiles might make the ground slippery and make it so you skid on it. Some tiles might be walls that block you. Some of them might just be for appearance, like grass. But that technique can be used for a variety of games, including kind of side-scroller, platformers, top-down, RPGs, 2.5D real-time strategy games, even 3D games, or puzzle games is one I left off that list. But there are a whole lot of ways you can use tile-based worlds to do that. And the nice thing about them is they also allow you, as we're going to see not in today's lecture, but in the future, they allow you to make really large worlds without having to have really large graphics asset, because we're kind of building up the world by sticking those things together. Now, let's to give you a better idea of what we're talking about here, let's look at a few examples of tile-based games. So we'll start off with some classics. Here's Mega Man on the NES, and you can kind of see that this is kind of on a grid. There are ladders, there are also bricks, there's the steel-looking stuff, there are these bricks over here, but you'll notice that this is like a grid where it's just had these tiles placed in there, and a lot of the NES games were like that. So for example, Legend of Zelda, a little bit different. This is more of a kind of platformer scroller where you can follow this and it'll follow you up on Mega Man. But if you look at Legend of Zelda, it's like a map of tiles, and you can walk around, and it's kind of like a top view in some way of that. And then Super Mario Brothers is like a kind of side-scroller platformer, however you want to think of it. But you'll notice the tiles and the bricks down here, and the tiles that you interact with, some of which coins pop out of, some of which are just bricks, some of which you can stand on. And then you notice these tiles in the background that make up kind of the background imagery. And then also Metal Gear, again on the NES. This is like more of a 2.5D, so it looks like you're kind of looking down on the world, but these are still composed of tiles. So the players can still run around here. And in fact, in some cases like this player could run partially behind the truck with their feet. But you'll notice that that's also a tile-based game. And a lot of those NES games were tile-based because the NES had hardware and a system that was set up to kind of support that kind of game structure. Here's some more modern examples that you may be more familiar with. Terraria. If you look at Terraria, you can kind of see the ground being built up out of these tiles, and even the background images. And the players kind of move around and interact with those, stand on that. And Terraria is kind of cool because you can actually interact with the tiles and change them. So for example, you can dig and the tiles will change, and you can actually dig down into the ground. And that's the players interacting with the tiles and changing the tiles as you interact with them and mine them or whatever. Civilization is another example of a tile-based game, more of a real-time strategy game, kind of looking down on that map, where it's kind of 2.5D rather than a side scroller 2D like we have over here, or platformer 2D like we have over there. And League of Legends, actually the map, the ground part of the map here is tile-based as well. Now the action kind of happens on top of that, but it's still tile-based, and you can kind of see that in the way that map is rendered. All right, a couple more here. The Sims, again, another 2.5D orthographic projection. Some funny stuff going on in this picture with a fire on the stove and the Sam like having a meltdown about it and the pizza on the floor. But anyway, also Ultima Online, and you can kind of see the orthographic projection 2.5D on both of these being tile-based. You can see that at play in both of these. And then a couple other ones that maybe you're familiar with that are fairly recent. Into the Breach is one. Factorio is another. And you can kind of see the tiles kind of knitted together in each of these. This one's more orthographic, 2.5D. Factorio is more of a traditional tile-based, sort of 2.5D, but not kind of at this angle projection like that. And a couple other ones that I've seen recently. Mindustry, which is kind of a strategy game where you make all these factories and connect them together and harvest energy and stuff from that. And then there's Dead Cells, which is kind of a platformer game. Pretty graphics, but you can also see kind of the tiles at work in this as well. But the idea is there's a lot of different stuff you could do with this tile-based kind of game creation. And we're going to get started today looking at how to make a simple 2D tile-based environment. And then what we're also going to do today is we're going to add a little bit to that simple 2D environment and add a character onto it that can kind of interact with those tiles. So before we do that, though, I want to do a quick review of Blitting. And what Blitting is, Blitting allows us to essentially, well, first off, what Blit stands for is essentially block. So if you look at the word Blit, I'm trying to see if I have Blit on here somewhere. Yeah, right there. So block image transfer is what Blit stands for. So BL is block, I is image, T is transfer. So Blit is a block image transfer. So what essentially it's doing, it's copying a rectangular region of pixels from one image or one surface and putting them onto another. So here's a simple example of doing that. I create the display surface called DS. I load this image called bricks.jpg into bricks_image. And now down here, I'm calling bricks_image. I'm using the bricks image and blending it onto the display surface. And let's take a closer look at the individual parameters or arguments for that Blit function, the Blit method of surfaces. And so taking a closer look at that, this is the destination surface. So we're copying the image onto the display surface. The source surface is where it's coming from. So we're copying, what are we copying onto the display surface? This bricks image. And then here is the upper left corner. This is the upper left corner on the destination. So in other words, it's the upper left corner of the bricks is going to be at 200, 200. And then over here, this is a source rectangle from the source surface. So if we leave that off, it'll use the entire image, but we could also trim that image down. And that is going to be useful to us a little later on. We're also going to use a concept called subsurfaces later on. But the idea here is that can be useful for loading an image off of a sprite sheet, in other words, or a tile set. So you load up one image file that has all of the tiles that you're going to be using, or a large number of the tiles you're going to be using, and you can cut out just the portion you want for one single tile and use just that one. Now we probably don't want to necessarily do that with the Blit every time. We could actually pull that out into a subsurface and use that. When we get to that part, not this class, but next class, we'll look at how to clip out a subsurface of an image. Now, as far as the tiles used, we could load them individually as individual graphics files, like these bricks textures over here. That would be one file. That would be another file. Or you can use a sprite sheet or tile set graphic, and that allows us to store many tiles in a single image file. So you might have this is like, you can think of this as like the palette of all the tiles we might use. And if you look at that, there might be grass, there might be stone, there might be rocks, there might be rubble. And you could really have as many of these kinds of tiles as you want, as long as you have enough memory to load that into memory. But you'll notice that you can even have bushes and trees and things like that that are loaded up as part of the tile set, and brick walkways and gravel walkways and water. So there are a whole lot of things you can load up, and this is obviously not a comprehensive set. But one of the things about the tiles is they tend to be uniform size or composed of blocks of a uniform size, and we're going to do that today as well. So you notice waterfall, a lot of stuff that you can have in here. including slight variations in things to give it a more organic look. Now, the screen, when we go to tile things, is usually divided up into equal-sized tile cells. And those are usually square, as we see over here. But they could also be triangular, hexagonal. And there's also, with the case of those orthographic projection ones, sometimes diamond shapes, where, for example, in... here, I'll show you one of the diamond-shaped ones. Just hold on a second. We'll go back. Right here. Notice these are kind of diamond shapes. So they're squares, but at an angle. So you could also compose the tile set out of those kinds of things. And if you look at some of these other examples here, some of these are hexagonal. For example, Civilization uses a hexagonal grid system. But you could also use triangles. But a lot of the type we're going to look at today is rectangular, so kind of like this or this. And actually, here's a hexagonal ones being used down here. Here's rectangular ones being used up here. And there may be other games that you're familiar with that you've seen this kind of thing in, being done in. Tons of games actually use this technique. All right, so as an example, let's start off with our 800 by 600 screen. And let's say the tiles themselves, each tile is 32 by 32 pixels. So this is a little confusing because it says 32 by 32 tiles as if it's 32 tiles wide and tall. This is a 32 by 32 pixel tile for each of the tiles. So how many tiles wide does that make the screen? Well, if we take 800 and divide it by 32, we get exactly 25 tiles wide. If we take 600 and divide it by 32 for the height, we get 18.75. Now, notice that that's a partial tile at the end there. And there are a couple things we could do with that. One thing we could do with that is either make it 19 tiles tall, but then a tile will have a quarter of it cut off at the bottom. Or what we're going to do today in our example is we're going to make it 18 tiles tall, and then that extra 0.75 of a 32 pixel tile is just going to be blank, but we can use that to put like the heads-up display information like the score or the health of the player, the health bar, whatever we want to put down there, armor, how much gold you have. You could put whatever you want down there in that bottom. And really, since we're the ones programming this, we could use a different size tile. We could use 16 by 16, or we could use 64 by 64. They tend to be powers of 2, but there's no law that says it has to be. We could use a weird 11 pixel tall tile if we wanted to. But we're going to use 32 by 32 today, and we're just going to cut off the extra one, so leave a little black bar at the bottom. All right, so here's an example of what that screen looks like in tiles rather than in pixels. So this is basically just, I put a grid on here to show each of the tiles. So this is 25 wide. If you count these up, they're 25. And it's 18 tall. If you count these up, you get 18. And you'll notice there's the little black bar at the bottom of that does not have a grid in it. We're going to use that to put information later if we want to. All right. You could also shift that down and have the black bar at the top if you wanted, or you could divide it and have an even border on the top and the bottom. We're just going to do it like this. Now, each of these tiles has a column and a row. Rather than using X and Y for that, we're going to use column and row. So column is kind of how far across we are. It'll start at 0. So this would be 0, column 0, column 1, column 2. And since they're 25, the one over here would be column 24. And then going down the rows, this would be row 0, 1, 2, 3, all the way down. And since there are 18 of them, row 17 is at the bottom. So this tile up here is row 0, or column 0, row 0. This one over here is column 24, row 17. Excuse me. Okay, so this is what the tiles look like. Now what we're going to do though is rather than have it just be a grid, is we're going to plug in tile textures into that. So what we're going to do is we're going to now write a little bit of code. So I'm going to switch over to Python, and we're going to throw some code together here that actually shows off creating a simple tile map first. So we're going to start off with some simple tile examples, And then we're going to move on to adding a player that interacts with the tiles, kind of runs around on top of it. And then we're going to look at starting to move towards storing the map in a string. And the advantage of storing the map in data is what we're eventually going to be able to do is store the map as a level in a file and load that up. And that's what we're going to look at next class. But today we're going to just focus on the tile code, getting that created. And we're going to see where that gets us. Let me pause for a second and get the Python set up and get the tiles in a directory where we can look at them. And then I'll be right back with you. So take this time to take a little break. Maybe if you want to follow along, bring up a Python editing window, program editing window in PyCharm or idle, and we'll get back to this here in just a second. Okay, and we are back, and the thing that I did is I had created these little texture files, these tile files, and I have brick1.jpg. The I we're going to use later on, and I actually just created these in GIMP real quick. The brick texture it is one that I actually took a picture of my brick wall here in my building and then edited it so it was a little less seamless. And then the ladder one, I kind of took that brick texture and I made a black box over it and I made these little ladder rungs and I tried to make it so that tiles nicely as well. So you can make your own tile sets pretty easily. If you're artistically inclined, you can do a much better job than I did. In the eyeball, I basically just made a white circle, another circle, put a little black circle in the middle of it, put a little circle on there for the lens flare, and then I used the paint tool and painted these little red bloodshot vein looking things around the outside. But now that I have that, what I'm going to do is I'm going to go ahead and start doing some programming, but I'm going to use these brick1, I, and ladder as my tile set. So we're not going to do anything super complicated right now. Later on in the future, we might add grass textures and other things like that. But what we're going to do first here is get started making just a simple overview of how these tile-based systems work. So let's go ahead and kind of get started on this. And so what I'm going to do in my code is I'm going to switch over to this coding window. And I'm going to start off, and I'm going to give this a comment. I'm going to say tiles1. And I'm going to give it a little description. This is just going to be a basic tile map example. Now, later on, we're going to convert this to a more object-oriented way of writing the code. But for right now, we're going to do it in a kind of with functions. And then we're going to move it towards having more of like a tile game world class object that we're going to use later on. But right now I'm just going to use functions because we want to focus on the tile part of it. So the first thing I'm going to do is I'm going to do my traditional stuff. So pygame.init and make the display surface. So pygame.display.setMode. We're going to put 800, 600. If you hear weird noises, there's a dog in the room rolling around and stretching. Now, so after we have set up the that, I'm going to go ahead and before I do anything else, well let's do what we usually do. Let's get the actual kind of shell of this working first. Let's do a while true. Let's do pygame.event.pump. Let's do keys equal pygame.key.get pressed. And let's say if keys subscript pygame.k underscore escape. So if that's true, break out of the loop. Now in the main loop, what I'm going to do is I'm going to clear the screen. So ds.fill, and this is stuff we've done many times before. And then I'm going to want to do a pygame.display.update. And then after the loop ends, pygame.display.quit. All right, so the typical stuff we've done in all of these examples. And let's go ahead and run that, make sure that works. Actually, I'm going to do a save as because I'm going to need to save that in the same place that I have those tile things saved. So let's go back to I've got to go to this class. So I'm going to save it here, and I'm going to call this tiles1.py. Okay, so there's that. Let's go ahead and run this. Oh, pygame not defined. Oh, we didn't import it. Amateur. All right. There we go. And I misspelled pygame somewhere, so let's fix that. Pygame, right here. Pygame. All right, and this is why we're running this now. Make sure we get that working. So there it is. There's a screen. We hit escape. It closes. All right. So all of that now works fine. So now let's add some Tilemap code to this. And in order to add that Tilemap, what I'm going to do is I'm going to load those textures in. So to load those textures in, I'm going to do that up here. And remember, that's pre-loop. We don't want to keep loading them over and over again. And notice you're probably used to that when you're playing like a AAA title, that before it loads a level and launches something, it has to load a bunch of stuff in. We're going to do that here too. So before the loop, we're going to load in those textures. So I'm going to say brick equal pygame.image.load. And if you remember what that was called, it was called brick1 dot, I believe that was a JPEG. So there are the bricks. Now let's load a ladder. Ladder equal pygame.image.load. I think that was just called ladder. JPEG. And then we had one other one, which was the eyeball. So I'm going to say I equal. And you know what? I'm not a big fan of these extra spaces, but some style guides like those or require them. So pygame.image.load, and this one is going to be I dot, and that one was a PNG. I know that because I created it with transparency. All right. So there are my three textures that I've loaded under the names brick, ladder, and I. Now, the other thing that I want to do now is I want to create a blank tile map that has the right number of rows and the right number of columns. So in order to do that, I'm going to do like this. I'm going to say tile map equal empty list. Now, it's an empty list right now, but I want it to have the correct number of rows and the correct number of columns. So what I'm going to do is I'm going to do a for loop and say for I in range, and I'm going to go through a for loop for every single row. Well, there were 18 rows, so I'm going to say for I in range 18. So we're going to go through 18 times. And what I'm going to do is I'm going to say Tilemap Dot Append, and what I'm going to append to that is a list that is 25 things long. And the way I'm going to do that is like this. I'm going to say none times 25. And this is actually pretty clever, because what I'm doing is I'm taking the value none, a list of just the value none, and I'm doing this kind of repetition on that. So I'm getting a list with 25 nuns in it, and then I'm repeating that 18 times and appending that. So I have a list that has 18 things, and each of those things has 25 things, and they're all none right now. And none is that special value in Python that essentially means there's nothing there. So right now I have a blank tile map that's completely filled with just values of none. And to verify that, let's just do a quick test here and say print tile map. So if I print the tile map and run that, that's what I have. And that looks a little overkill there in the background. Here, let me actually escape out of this. But you'll notice that the organization of that, let's go to the very top, is it's a list that has a list of 25 nuns, goes all the way to there, and then another one, and another one, and another one. Now, if we wanted to, we could put something else in there, like zeros or little strings with nothing in them. But we're going to use none for right now. So that has created that. And what I'm going to do to get this to render the tile map is the first thing I want to do is I want to make a function that actually fills stuff into there and replaces some of those nuns. So I'm going to say init tile map. I'm just going to make this function, and I'm going to call it. Now we haven't made that function yet, so we're going to need to make that function. So let's go up there and do that. So let's put that up here at the top of the code. Let's do the Init Tile Map function. So I'm going to come up here and add a function. And actually, let's go ahead and put it like right at the top of here. So let's say def, and I called it Init Tile Map. And we don't need to pass anything in, but this is going to set up the initial map. It's going to put the things into there. So I'm going to do something relatively simple. I'm going to kind of make a border around the outside, maybe make a little platform, maybe add some ladders that go up to the platform. But to show how I'm going to do this, well, I'm going to be editing that tile map structure, which is a global. So I'm going to say global tile map. That's the thing that I created down here. That's that list that's filled with nuns right now. And now I'm going to go through, and first I'm going to add the top and the bottom. So let's do that. Add top and bottom as all bricks. And I'm going to do this with just a for loop right now. So I'm going to say for column in range. And here it's going to go from 0 to 25. And I'm going to put both things there, even though it starts at 0 automatically, just so you can see that. So this is going to go through all 25, 0 through 24 in column. Now, how do I put a brick in that spot? I'm going to say tile map sub 0. So that's the row. And then the column is going to go here. So column. And that's going to be equal to the brick texture. So I'm just sticking that actual image texture reference into that tile map. So that's the top. Well, how would we do the bottom? Same thing. But rather than 0 here, I'd put the last one, and we set that one to 17. So that puts bricks along the top and the bottom. So let's do the same thing, but let's put bricks along the left and the right. So I'm just going to copy this, save a little bit of time, add left and right as all bricks. And this, rather than column, I'm going to change the variable to make it more clear and say row. And this, rather than going 0 to 25, we already did the stuff at 0, so I'm going to say 1 to 16, because the last one is 17, and we already did the bricks at 17. So 1 to 16, and what I'm going to put in here is row, comma, and here's going to be 0, and row here. And here, this is the last column, which in our case is 24. And we're setting that to bricks. All right, so that gave us a set of bricks in the map. And before I add anything else, let's actually write the function now to render that tile map, to go through and draw on everything on the screen. So let's make a function for that. Def render tile map. And the code for rendering that, well, basically we want to go through every row and every column. So for row in range 0 to 18. For column, and actually 0 to 18 it needs to be 19 because it goes up to and not including that. We want to get the 18th one. So for column in range 0, or actually it doesn't need to be 18. No, the last one is 17, so this does need to be 18. All right, so for column in range 0 to, the last one is 24, so this needs to be 20 or 25, so we need that to be, the last one is 24, so this needs to be 25 because it's one less than that. All right, so now we have our nested loop that's going to go through every row and every column. So for every row, we're going to go through every column. And what am I going to do? I'm going to say if tile map at that row and that column is not equal to none, that means it's got a picture in it because it was filled with none until we put some images, surface images in there. So if it's not none, then we want to go ahead and blit that. So we're going to do ds.blit. That's our destination. We're blitting onto the display surface. Now, what are we blitting? Well, whatever image happens to be in our tile map at that position. So tile map sub row sub column. And now we need to specify the destination where we're putting it at. Now, the idea here it would be that we have to we can't just put 0, 0 here because it will put them all over the top of each other. They need to move, but they need to be at a position that's based on whatever row and column we're on. So the column is associated with X, so this is going to be column, but we can't just put column and row like that because these only increment by 1, but the pixel positions increment by 32. So to accommodate that, we're just going to multiply these by our tile size, which is 32. And there we have our thing that's going to render the tile map. So with these two functions, this one's just putting things into the tile map. What's it putting in there? It's putting the images into there. We've just made a box around the screen. Now, down in our code, we have already called Init Tile Map, which I think I need to fix the spelling of. A capitalization problem there. And now in my code, after I clear the screen, I'm just going to call render. Render tile map. So there we have it. So our main program is just clearing the screen, rendering the tile map, doing a pygame.display.update. It's repeating that over and over until we hit escape. So let's run it and see if it actually works. Oh, typo. I left out the word in up here. In. And there we go. And we were 1 off on the tiles here. So we need to add 1. Yeah, that's right, because it goes 1 less than that in the range. So let's fix that. So that was in our code here. This needs to be 17. And there we have it. There's our border around the outside. But let's make that a little more interesting. In order to make this more interesting, I'm going to add a little platform in here. And I'm going to make a little ladder that goes up to the platform. So if we think about where we want that platform to be, that's going to be changing a column, or a column to go across like this. And let's make it maybe at that column go maybe 10 down. And we'll start at 10 and go, I don't know, up to here somewhere like 18. So let's go ahead and add that first. And what's cool about this is we can now just change this function up here. Let's do a 4 columns, because that's moving across to make a platform, in range. And I think we said let's go from 10 up to 18, so that means we're going to put a 19 there. So that should be 8 cells wide. And what am I going to do? I'm going to say tilemap row column. So we're replacing some none values in here. And we're going to set that, well, row column with a row. We need to specify what row we want on. Let's do 10. Equal. And let's make that brick. Now let's make a ladder that kind of goes up to that. So it's going to be a 4 row in range. And let's make that range, let's see, we were at 10 here. So let's go 10 all the way down to 17, which is the floor. And then we'll do tilemap row. And what column do we want to put this in? Well, this one finished at 18, so let's put it one tile past that. So let's go and put 19 here. So that should go right up to the edge of that platform. And let's make that, instead of brick, let's make that a ladder. And let's put some comments on here. So this is make platform. And this one is make ladder up to platform. All right, let's run it and see what we get. Okay, so there we have exactly what we wanted. Our platform that went across to there, our ladder that went up to it. And you can see how it kind of seamlessly blends in with that because I left a little brick texture on the side there. And if we wanted to, we could then make a ladder coming off of the top of this platform going up here to another platform up here and maybe one down here. And we could put whatever we want together to make that do whatever we wanted it to. So the next thing that I'm going to want to do is add a a character, add that eyeball so that it can move around and interact with this map. So basically move around inside of this map. So what we're going to do is we're going to take a little break. I'm going to pause the lecture here. If you want to get caught up on where we are now, let me close this out. Let me put this on here and scroll down this program slowly so you can see the part. So there's kind of page 1 of the Init Tile Map function. So if you wanted to pause there and write that function up yourself, feel free to do that. I'll leave it there for a couple seconds so you can have time to pause it. And then let's go down to the render. And you can play around with changing these values and putting different platforms and different ladders. Scroll down to, here's the render tile map function. Here's the code that loads the things and initializes the tile map. But really, we could move this into the init tile map function. So I'll leave that there for a second. And then the main is very simple, and I'll leave that there for a second. So if you want to pause this, take a chance to recreate this yourself. And if you want to make your own tiles, your own graphics, feel free to do that. If you want to download the ones I have, I'll upload these to the web page, the course page, a zip file that has this code example along with those assets that are being used in there. All right, I'm going to pause here for a second and give you a chance to work on that if you want to, and then we'll resume here in just a second. Okay, now what we were going to do for this next version is we're going to add a little bit to the code here to add a character that moves around and interacts with that map in some way. So let's go ahead and do that quickly. And what I'm going to do is I'm going to make this tiles 2. And I'm going to do a save as so I don't accidentally overwrite this one. So to do a save as, I'm going to do File, Save As, and I'm just going to change the name of this to Tiles 2. And this is going to be basic tile map example with character. All right, now the thing that we're going to add to this is the init tile map. We'll leave that the same for right now. Render tile map, we can leave that the same as well for right now because that's not going to change anything. But what we want to add is we want to add this kind of player character. So what I'm going to do is that's going to be our eyeball. So I'm going to give it a variable ix. And let me just start it at somewhere on the screen. I'll put it at 100, 100. So ix, y. Now, one of the things that's important to note here is the way we're representing the position of that is in pixels, not in its position within the tiles. Now, if we wanted to, we could represent that as tiles, but that would mean that if we moved it in whole tiles, it would kind of jump on the screen as we moved it. Now, we could do tiles with fractions, like it's at 10.5, 10.6, 10.7, and we can move it around that way. But for right now, I'm just going to keep it as pixels. We could switch that over later if we want to. And what I'm going to do is now I'm going to add the ability to render that on the screen. So to render that, I'm going to make a function for that. So I'm going to compare what my functions are. I'm going to say def render player. And maybe we could call it render I guess, just to make it clear that that's what we're talking about. And what we're going to do to render that player is we're just going to blit that eyeball texture to the screen. So that's going to be like the blit we did above. You can see the blit we did above up there. So ds.blit. And here, rather than tile something that's stored in the tile map, what I'm going to put here is just the I texture, which was under I. And where are we going to put it? We're going to put it at I, X, I, Y. So that's the destination we're putting it at. And really, that's all we need for that render tile map thing. And so now if I put in my main loop here, if I put render the tile map and then render the eye, and I run that, you'll see there's the eyeball. But right now, we have no way to move it. So I want to add some code to allow that thing to move around on the screen. All right, so how are we going to move that? Well, the same way we've moved stuff in previous examples. We're just going to change its X and its Y. So I'm going to add some keyboard input here. So I'm going to say if keys, and let's just do WASD, so pygame.k_a. So that will be moving it to the left. So that's going to change its X. So I X minus equal 1. Let's move it by 1. That's A. D will move it to the right. So plus equal 1. And let's do S. It's going to be Y plus equal 1. And maybe I should do these in the order like this. So let's do W is Y minus equal 1. So let's go and run that. And now notice I can move the eyeball around. But one thing to notice is that I don't have it interacting with those tiles in the background. Right now it's just moving around on its own. We also don't have it contained on the screen. So it can leave and come back on. I can even do some weird stuff like go off here and then come back on there. Now, we want this to be able to interact with the tiles on the screen in some way. So in order to do that, I need to know, is this eyeball, is that tile, that 32 by 32 pixel rectangle, is that colliding with the 32 by 32 pixel rectangle of one of these tiles? In other words, are the tiles that it's colliding with, do they have none in them, or do they have something in them? So we're going to write a little function that actually helps us determine that, to check the collision with the tile map. So let's go ahead and do that. So in order to do that, the thing that I want to do is make that check tile map collision function. So let's go ahead and look at how to do that first. So in order to do that, we basically need to, here, let's go up to where our functions are. And I'll go and put that like here. So let's call it check tile map collision. Now, when we go to check that collision, we need to know what we're checking against. So here I'm going to pass in an X, a Y, and a width, and a height. So this is the rectangle that we're checking for collision. We're going to check that rectangle, and I suppose I should spell width correctly. We're going to check that rectangle that we're passing in and see, does that collide with any tiles? Are there any tiles in that region that are colliding with the thing that we have now? So in order to do that, the way we're going to do it is we're going to go through every single tile, and if that tile has something other than none in it, we're going to check to see, does that tile have some collision with the rectangle that we're checking right now. So here's how we're going to do that. So first off, how do we go through every single tile? Well, we're already doing that up here. So I'm just going to kind of rip off this code here that we had up here. And then we're saying, we want to say we only care about checking ones that are not none, just like we did when we were drawing them. So now we're down here. So now how do I check the collision? So that's what we're going to do. So check to see if this tile collides with the rectangle that was passed in. Now, it turns out that there's a more efficient way to do this that we're going to look at next class. Because right now, why go through all of the tiles, every row and every column, checking every one? We only really care about the ones around where we are. But we'll look at optimizing it later. So let's go through and do this kind of a more simple way right now. All right, so here's what we're going to do. We know that we want to calculate, since this is being passed in pixels, and this down here is just rows and columns. Let's convert those to get the rows and columns. So I'm going to say tile X x min. So this is the minimum of the tile x that we're on. That's just going to be column times 32 because there's 32 pixels for each tile. So in other words, if I were to put a comment here, this is going to be the left pixel of the tile that we're on. Now, what's the maximum of x of that tile? So tile x max is going to be, well, it's basically just the min where we are now plus 31. So that's one less than the start of the next tile. Because where we are now would be 0. We had 31. That's a total of 32 pixels wide. So that gives me the first pixel of where we are now and the last pixel of where we are now in x. We're going to do the same thing in y. So to do the same thing in y, I'm actually just going to copy these lines. Change that to y. Change this to row. And then this, rather than being the left, is going to be the top. And then we're going to change this to y. Change this to y. And this is going to be a 1 less than the start of the next tile's top. All right, so now we've done that. Now we're ready to actually, now we know the tile that we're on now, what its x coordinate and y coordinate ranges are. We want to see, do any of those fall within or overlap with the rectangle that was passed in. So to do that, we're going to say if tile x max. So if the x max is greater than the x that was passed in, and the tile x min is less than the x that was passed in plus the width. So notice what this is saying. We're saying the x that we're checking that was passed in, that's kind of the left of the tile or of the rectangle that was passed in. That's over here. We're saying, hey, if that is in the region of the tile and the minimum, or so if that's greater than the left of the tile and the minimum is less than x plus the width, so the other side of the tile, then we know that those things are overlapping each other. But not only does that have to be true, but it also has to be true in y. So in other words, we're saying, does that region overlap in x, and if it overlaps in some way in y. So the only way they don't overlap each other in some way is if this one is outside on that way or outside on that way. But if any of the other cases are true, then there's an overlap where one of the two ends falls within this region. And that's what we're checking for. But we need to check it in both x and y. So to check it in y, we're also going to check if that's true and tile y max is greater than y and tile y min is less than y plus, instead of width here, this needs to be height. Then that means there's a collision and we're just going to return true. Now, if we get all the way done with this whole loop and go across the whole screen and we've not had any of them return, there was no collision, so we're going to return false out there. All right, so this function is checking the tile map collision. So essentially, here, let me put a comment here. So this is kind of rectangle collision that we're doing here. And like I said, there's a more efficient way to do what we're doing here that we'll look at later. But now we need to use that collision function some way. So in other words, when I'm moving this character around, the eyeball around, what I want to do is if there was a collision, I want to like move it back to where it came from. So in order to do that, that's going to be really easy. So what I'm going to do is I'm going to remember where it came from. So I'm going to say old I, or let's call it ix old. So I'm remembering where it is, both its x and its y. Oh, that should be underscore. I hit the wrong key. So we've remembered where it is, and then what we're going to do is if it happens, the new position we picked is colliding, so if, and now here we're going to check that collision. So check tile map collision, and we're going to check it against I, X, I, Y, and the width and height of that's 32 by 32. So if that ends up being true, then move it back to where it came from. To move it back where it came from, it's just going to be the opposite of what we did up here. So let's put some comments on this. So this up here, that's remembering the I position before the move. And then down here, let's add a comment on that. This is going to be if it collides in the new position. Then move it back where it came from, as if the collision was stopping it from moving. Now, we just need to fix this and make that old. And this one, old, like that. So we remember where it was, we try to move it. If where it moved to collided, we put it back to where it came from. Let's try it. So there's our tile, there's our eyeball, it's moving, and donk, and notice it will not allow it to go through any of those. Now later on we're going to assign different types of tiles when we make this more kind of object oriented and simplify it a little bit. But we're going to make it so that you could go across the ladder but not across the platforms, for example. There's also ways you can make this if it's moving in the upward direction, it'll go across it, but in the downward direction, it'll collide. So for example, in games where you could jump up on the platform and still stand on it, so you jump in front of it and stand on it, we could actually add some code to do things like that. But now we have some code. We're also could add gravity to this, so the eyeball falls down, it hits and bounces. We can add friction when we're on the surface. We're going to do some of that next class when we add to the code we've done so far. Now, there's only one other thing I want to do today. So the kind of third program here. So this works. And you can kind of start to see how you can make games out of something like this, where you run around in the maze, can't walk through the edges, collides with it. Okay, pretty cool. All right, now the last thing that I want to do today is I want to add the code that rather than storing the map as just this giant bunch of none values and this set of init tile map like this, I want to make it so it's more data driven. So rather than having code create the map, I want to create the map with a string. So what we're going to do is we're going to take a look at how you would do that. And the way that we're going to do that is we're going to modify this code a little bit and make a version of this that is where it creates the tile map from that string. So really, we're just going to kind of change this init tile map function, but we're also going to change some of how the rest of it works as well. And I'm going to show you how to do that. So what I'm going to do is show you how I want the map to be. And so the way I want the map to be is I want the map to be composed of a bunch of strings that are either like 2 character long strings that are representing the map itself. And the idea there is, and I'm going to take this init tile map thing, and I'm going to take all the stuff out that we have in here right now. And what I'm going to add into here is I'm going to say map 1 string. And I'm going to show you what that string is going to look like. So I'm going to make a triple quoted string, which allows me to make a string that crosses multiple lines. And what I'm going to put in there for that string is going to be let's say B1 represents bricks. So I'm going to put bricks around the top. And we need to count up how many of these we're putting in here. And remember, this is 25 cells wide. Or, yeah, 25 wide. So we need to have 25 of these, which means we need to have a total of 50 characters, because each one, so that's 1. So if we count them, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So that's my map going that way. Now the cool thing about using a triple coded string is I can make that cross multiple lines here. So I'm just going to kind of draw a picture of what I want the map to look like. So B1. And all the way down here. B1. So let's go ahead and make the borders of this first. So this is line 1. And we said that we need to have 18 totally. So that's line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then 18 is going to be the bottom. I'm going to copy this line up here. All right, so now I have the outline of my screen. It has the right number of characters going across, the right number going down. And the other thing that I'm going to do is let's add some stuff in the middle in here. So let's do, let's make sure we're lined up on a border here correctly, right there. So right here, maybe here, let's add ladders as L1. Maybe put one coming down here. Maybe one up here. Oops. We need to make sure that that side stays lined up correctly. And let's put a platform here. So that's B1, 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 B1. And actually, let's put a ladder coming down out of the middle of this here. And let's put a platform underneath the ladder down here. B1, 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 B1. And now let's put a ladder coming down off the end of this. Actually, let's just going to change that to a ladder. But notice the nice thing about this is we can kind of see the level taking shape by how we're drawing this kind of ASCII art image of it. But now the trick is to getting this to work right is we need to now somehow associate these strings B1 with the bricks texture and L1 with the ladder texture. So we need to somehow create some kind of thing that associates. When I say, hey, I want to have texture B1, it knows to get the bricks. When I say give me texture L1, it knows to give me the ladder. So how are we going to do that? Well, the way we're going to do that is we're going to create a dictionary, which is a thing that associates some object with another object. In this case, we're going to associate B1 with bricks and L1 with ladder. So to look at how to do that, let's come down where we loaded those things, and we're going to make that thing happen down here. So there's where we loaded it. So what I'm going to do is I'm going to make a dictionary. And in this case, before I do anything else, I'm going to say tile map texture. Let's call it textures. And to make an empty dictionary, if you remember back from a few lectures ago, use the curly braces. Now that I've created that, I can just set what I want in that. So I can say tile map textures, square bracket, and in here I'm going to say B1. What do I want to associate with B1? I want that to be the brick texture that I had up here. So I could say brick here, or I could just load that up and get rid of this line up here altogether and not have the word brick anymore at all, and just do that. So notice I'm loading the brick texture into this dictionary and filing it under the heading B1. So when I look up B1, I get this brick image. I'm going to do the same thing with the ladder. I'll just copy this line and paste it. And I'll say, okay, the texture for ladder 1, L1, is going to be ladder.jpg. And I'm going to remove this up here. Now I'm still going to load the eye up rather than pulling it out in the texture because we're drawing that kind of separately. But I have that now. But because I'm doing this way, now I still need to call that, and let's move this up, or this init tile map. Let's look at what we need to do with that. We need to actually create that from that string we had up above. And so in here, I want to take that thing, that giant triple quoted string that we created, and I want to go through that and essentially create that tile map array from that. So here's how I'm going to do that. I'm going to say and we called that tile map. So tile map equal. That's going to start out empty. And actually, let me take the code that we had originally used down here to set up that tile map originally. This, because we're going to copy that kind of way of doing it. And now we're doing that inside of the init tile map function. Okay, so we're going to go through 18 times. And then what are we going to do? What I'm going to do is, rather than appending none 25 times, what I'm going to append or stick into this tile map, instead of none, I'm going to make that this kind of empty string with 2 spaces, because we want all of them to have 2 spaces as they're stored in there. So I'm creating it as being completely empty right now. So this is the same thing we did before, it's just now it's filled with empty strings that are 2 spaces each rather than that. So the next thing I want to do is now I want to go through this string that we have up here, which, if you remember, we called that map1 string. So here, I'm going to call that, well, first thing I'm going to split that into individual lines. So I'm going to say lines equal map1 string dot split. And I'm going to split that string on a new line character, which is the end of the line. So every one of these things at the end of the line has a new line character that's in there that tells it to go to the next one. So by splitting that, I now have all of these lines. All of the lines of that are now in a separate list. But now what I want to do is I want to go through those and divide them up into groups of 2. So I'm going to make a variable row, started at 0, because that's what row I'm going to start on. I'm going to say for line in lines. So for each line that's in that list of lines that I separated out of there, then what do I want to do? I want to go through for column in actually range 0 to 25. So for every one of these, every column I have here. And what I'm going to do is I'm going to say tile map row column equal line column times 2 through column times 2 plus 2. Now, to give you an idea what's happening here is, remember this slice is we're slicing this string. We're saying, hey, go to this position for what column I want, and then 2 characters ahead of that. So we're going to split out this. When it's 0, we're going to get the first pair. When it's 1, we're going to get the second pair. When it's 2, we're going to get the third pair, and so forth as we go through and split all these out. And what am I doing? I'm just sticking those over the top of that empty string, empty spaces that we had up there. So in other words, places that had something in there are going to get stuck in there. And I suppose really we could get rid of this and have just done an append here of each of those, but I'm going to keep that there in case we ever wanted to have just an empty map to start with. And then the last thing we need to do is every time I go through all of the columns, I need to go to the next row. So row plus equal 1. And when I get here, the tile map should now have everything in there. Now I need to make sure that I make that a global. And actually, let's make sure that we still have that down here. And actually, you know what? I want to change how this works. I want to say tilemap equal. I'm going to make that into a function that's called load. Or let's do tile map from string. And I'm going to pass that string into this. So I'm going to make a function that does that. So we could pass different strings in at different times to get different levels. So let me take this giant thing out of here. I apologize for this being a little confusing how I'm going about this because I'm kind of doing this live. But let's take that out of there. We're going to pass in that tile map string, which means I need to change this. Tile map string. That should be all we need to change in there. And let's not make this global anymore. And to make that clear that that's a different one, let's actually change its name to local tile map. And then at the end, let's return it. Okay, so in other words, same thing we're doing before, we just rearranged this a little bit. So let's go down and now paste that in. We're not using that function anymore. We changed the name of it, I think. Did we change the name of it? Yeah, let's change the name of it. Let's say tile map from string. And now down here, rather than calling it init tile map, we're just going to call that. And the string we're going to make here, oh no, we lost that. Hold on a second. I'm going to get a copy of it. Let me undo that. And put that in there. Okay, so there's my map1 string. So here, map1 string. All right, so we define our string. We call the tile map from string. That produces our tile map. And now we're ready to actually, well, let's see if this works. It's probably a problem, but we'll see. Tile map from string is not defined. What did I call it? Tile map from string. Okay, I had a capital M somewhere down here. Tile map from string. All right, let's try again. Okay, list index out of range. All right, let's see why that is. Might be because I had that extra line there. All right, well, let's add a print statement in here to see what's going on with this, to see why we're getting that. So we should have the right number of things in there. Map1 string, we're passing map1 string into the tilemap from string. Tilemap from string, let's print out the lines. Or let's print out the row and the column here right before I do this, and we'll figure out where the problem is. So it looks like it's going through all of them. Okay, we got to 18. All right, let's look at the code. We're probably having off by one problem in that code, so let's take a look. $18. We might have that extra, here, let's look at that string. I think that they were right there. I think the problem might be that this extra line here. Let's try that. Now really we should probably just throw out blank lines that are in that. So if the line has nothing on it, just ignore it. Okay, so now we're on the road to finishing this up. So that part is working correctly. So the last thing we need to do is take what we have now, and remember the render that we had up here earlier? Here we were, not that, that's the collision. The render's right above that. We're trying to blit exactly what's at that tile map location, but what's there now is a 2-character string, not an image. So we need to look that what image is there up in that. And so up here, there's 2 changes we need to make. This where it says not equal to none. We want to say if it's not equal to nothing, so spaces. So it's not equal to empty spaces. Then we want to pull the image out of there, which means we just need to look up the 2-character string in our dictionary, which you remember that was this Tilemap textures dictionary here. So we're going to just look up in the dictionary what the 2-character string goes to. So right here, we're going to say, look up in the dictionary whatever is in the tile map at that position. Now we could break this up into steps, but let's let me take out this print statement and slowing that down. Let's try it. And there it is. There's our map as loaded. Now, there's one other thing we have now, and that's that, notice it's always colliding. We can't move. And that's because we no longer have nones in there. We've got. So we need to change our collision and say if this is not equal to empty string like that. So let's try that. And here we have it, and there we can move around and still collide with stuff. And eventually we'll make it so you can fall off the edge. And you can go across the ladders and climb up when you're on the ladders. But right now, that's where we're going to stop today. And let me kind of go over again what's happening here. We're loading the textures into a dictionary. So B1 is associated with this image. L1 is associated with that image. If we wanted to, we could load grass. We could load metal beam parts. We could load parts of trees or little, could load treasure chests, whatever we want. We could load a ton of different things in there. But notice that the map, to change the map now, we don't have to change any code. We can, for example, change the map with just changing this string that we have right here. And so when we're dealing with changing that string, we can just add something else in. Now, one of the questions might come from is, what if I put in something that doesn't exist, like M1? I accidentally make a mistake and put that in. What happens? Well, what happens right now is we get a key error because it tries to look up M1 and that in that dictionary, and it doesn't find M1. It doesn't have that in the dictionary. We never defined that. So one of the things that I want to do before we finish completely here is I want to make one last change to this code, the way that's doing the rendering. And that is if the thing does not exist. So in other words, if that string is not in that dictionary, then I want to show that on the screen somehow. And this is common for 3D games as well. A lot of times if you're playing a game and there's not a texture that's not defined, rather than crashing, it visually shows you that that texture is missing. So let's add the code for that. So we're just going to quickly change the render, tilemap render. And what I'm going to do is I'm going to say if it's not that, then I want to check. And let's make this a little more real. Let's say cell string equal. And let's pull out the 2-character string that's in there. Pull that out. And now I'm going to say if cell string is in my tile map textures, then it's okay to blit it. Like that. But else, the else here is if it's not in there, then what I'm going to do is I'm going to draw like a rectangle here, and I'm going to make it like that bright magenta color to show that that thing was missing. So I'm just going to do pygame.draw, and let's make a rectangle. And I'm going to put it on the display surface. And let's make it a magenta color, which is lots of red and lots of blue and no green. And then the location of this is going to be kind of the same place we were going to put this up here. So col times 32, row times 32, and then the width and height is just going to be 32, 32. So now when we run that, oops, I need to put cell string in there. So now when I run that, you can see rather than crashing, I get that bright magenta color showing that, hey, that's a texture that wasn't defined. And notice since we're using those 2-character strings like that, it's easy to mess up and be off by one character. So for example, let's say that I accidentally have this line here, 1 space, backwards. Now you'll get a whole bunch of those magenta things on that one line because they're getting the wrong alignment for the characters. But you'll notice that if we want to add things to this code and change it around, it's really easy. Like I want to add another ladder up here, L1. Add another ladder there, L1. And then let's make a platform here, B1, 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 B1. I just changed data. And what we're going to look at next class is we're going to do 2 things next class. One is we're going to look at how can I store that map data in a file. In other words, how can I store that string in a file and load it up? And then you could have it when you get done with level 1, it loads up the file for level 2, and then load up the file for level 3, which means that you don't have to rewrite your program to make new levels. And that's true for a lot of games and game engines, is you store the level data in some sort of a file format, and you just load that stuff up, and you can have people have a level editor and edit the level and change the map around and edit things. It also gives us the ability to, for example, if we have a game like Terraria, where let's say that this guy can mine and dig down into this ground and change it and get rid of blocks, you could then save that off to the file, and the next time you play, reload it, and your world is how you left it, which is actually a pretty cool thing to be able to do. So we're going to do that next class, and we're also going to look at adding physics simulation. So when this guy walks off the edge of this platform, he goes and falls in a natural way and then bounces without me doing it with the keys and making my own sound effects. And then from there, what we're going to do in the next class is we're going to kind of make what we've done so far, which is kind of done with functions rather than an object. We're going to kind of move to make an object-oriented version of this kind of map system, and we're also going to make a move to make it a large map so you can scroll around inside it rather than just it's static on the screen. So we could have a really large map, and as we walk through the thing, it scrolls past and follows us wherever we go in that map space. So let's temporarily switch back to the presentation, and we'll finish things out. And I will post these examples in a zip file to the course page, so feel free to download them, look at them, and use them. But we did example 1, simple example with rendering the tile-based map. We added the player for example 2, and then for example 3, we stored the map as a string and used a dictionary to look up the textures, which is going to be much more extensible than what we did before, because now we can add a texture, change the map, add the things to the map, and have a whole different map show up. And we can. The other cool thing about this, as I said before, is you can see what that map looks like by how you're editing that file. All right, so we're done with what we're doing today. So that's it. So everybody stay safe, wash your hands, get your labs done, get your particle effects lab done, because we might, in the next couple lectures, add some particle effects. So when your guy hits the ground, like sparks come out or a cloud of dust comes up around him, or when you fire bullets through your map and they hit the wall, it makes sparks that come off of that. Or you fire bullets and they hit an enemy, the enemy explodes in like a cloud of particles. So there's all kinds of cool stuff we can do from here, but that's it for today. And this was a rather long lecture relative to some of the previous ones, but hopefully worth it. And you can start thinking about how you could use this for your games that you're going to create. Next class, we're going to add gravity simulation, physics simulation. And next class, we're also going to look at how to save those things into a file and make this a little more object-oriented as well. All right, that's it for today. Stay safe. And you should be watching these, by the way, all of them.